Hey guys, in this video we're going to cover section 1.3, which is a whole lot less than 1.2. But we're going to focus on what are the 12 basic functions. You may recognize most of them, but maybe not all of them. But they are just the kind of like the parent functions that you guys would have talked about, or your basic functions, before transformations have taken place. And they're the 12 different kinds that we want you to be able to recognize and tell us different attributes about. Okay, so we're going to start off here with probably the most basic one, the identity function, which is just a line. You're going to see the domain, all real numbers, and range, all real numbers. You can also use the symbol for all real numbers to mean the exact same thing. So that's that like R with like a double spine or something. Okay, that's how you would indicate that with just a little symbol. So, yep, that just means all real numbers. Goes from the left to the right for forever. It goes from the bottom to the top for forever. Never stops. All right, we have continuous. It never has any breaks in it. We have increasing from negative infinity to positive infinity. It never ends up decreasing. Now, if you were to throw a negative in front of that, of course, that would turn it upside down and make it go negative, but this is from its parent function, from the basic, original, simplistic form. It's increasing indefinitely, decreasing never. Symmetry, it is odd, so remember that means if you turn it upside down, it's the same as it is right side up. It is not bounded, right? Extrema, none. Horizontal asymptotes, none. Vertical asymptotes, none. In behavior, what this is saying is it's going to the left for forever, it is going down towards negative infinity for forever. And then the next one, as it goes to positive infinity forever, it actually moves up for forever. So as it goes to the right for forever, it goes up for forever. So it's kind of got that in behavior. All right, next one I have for you is a squaring function. Also, all real numbers for your domain. However, your range is a little bit different because it does have that lowest point down here where it turns. And so it does not keep going down. It has that, that lowest value where your y would be a 0. So your range goes from 0 all the way up to positive infinity. It's continuous, increasing for where that vertex was to the right, it increases. However, it actually started out by decreasing. So start off going down and then turned and went back up. Symmetry, y-axis, it's an even function. So if you, it's a mirror image on either side. It is bounded below at 0 if you wanted to get specific. All right, we have extrema. Yes, we have an absolute minimum right here at 0, 0. No asymptotes. In behavior on this one is a little bit different. So as it goes to the left for forever, the y's are going up for forever. As it goes to the right for forever, it is going up for forever. So that's kind of how we read those. All right, cubing function should also look familiar. So there's all of that stuff. I'm not going to sit and talk through each thing because a lot of this is stuff you should already know, but you'll notice that on each one of these functions, we are given all of those pieces of information. So the cubing function, big thing, you got your equation and your shape of it. Those are some things you want to be able to know. I know the cubing function looks like this, right? And you'll want to know pieces about it, but if you know what the shape is, you can most likely figure out a lot of these pieces by knowing what the shape looks like. Reciprocal function is where x is in the denominator. So you're going to see that shape here. It actually does create some asymptotes. So the y-axis is an asymptote, and so is your x-axis. If that was transformed, of course, that would change, but this is that it is not continuous because of those asymptotes. All right, we've got square root function. Again, that's if you square root x, and it looks kind of like a sideways parabola with half of it cut off. That's kind of how I see it. And I remember the shape of it because it's almost like the opposite of squaring, right? The squaring function is what parabolas are. This is square root. It's like half of a sideways parabola. So to me, that's how I remember them. I don't know why, but that clicks for me a little bit. All those lovely features. There is an absolute minimum where it does not go below. That's at 0, 0, unless it had been transformed, okay? I'm going to keep going. We've got a exponential function. I was reading the wrong one. Exponential function. And you would have learned about all of these things, and this one included, back in Algebra 2. You should have definitely had some experience with this. So there's your exponential function. We've got our natural log function. There we go. That's what ln means. A lot of people will say that's in. No, it's not. It's their natural log ln. Okay. Again, there's all of your information about it, so you can be able to reference that. We have a sine function here. So this thing is probably one you've not seen before. I think all the others so far you should have seen. This one, probably not, unless somebody just was like, hey, this is what this looks like, and didn't expect you to do anything with it. So you're going to see all the increasing and decreasing things. It's a little bit awkward because you haven't really learned all of this stuff, but it does use pi when we talk about the different intervals there. But that's something we will talk about much more later on this year. Okay, you can see the rest of that there. Keep in mind, anytime that you see this little z right here, I'll write this on here so that you've got it. But right here, this is talking about the set of integers. So like no decimals or fractions, right? They're whole values, positive, negative, and 0. All right. Next one we have is cosine, which is so much like sine. So a lot of times people will be like, how do I tell the difference between cosine and sine? So I want you to look here. I want you to see where it hits the y-axis. For cosine, it hits the y-axis here at a y value of 1, okay? So that's what that is. If I was going to write this as a point, I would actually say 0, 1, right? That's where it's hitting the y-axis. However, let me go back to sine for just a second so you can tell the difference. Sine, it is hitting the y-axis at the origin, 0, 0, okay? So that is one really key thing. Now, here's the deal. If I shifted this sine function left or right just a little bit, then it would look a whole lot like a cosine function. So it is possible to make sine and cosine functions look the same. They are bounded. They have a highest point and a lowest point, so that's fun. And yeah, they do look very much the same, and they have a lot of the same features. But look at that y-intercept. That's usually a pretty good tail sign. We do call them both like the sinusoid functions, and they have that same pattern. Okay, absolute value functions. This is one you should be familiar with already, so I'm not going to harp on it too much, but there's all of the information you should know about it. Again, you want to be able to relate the equation to the graph. And then these last two I don't think you've seen before, so we're just going to talk about them real quick, but not go into super depth with it. Here's the greatest integer function. You're going to see this situation happen where you don't get any decimals or fractions with your y values. You're only getting integers for all of your values. Okay, so f of x or y equals an integer. That's what that is saying. Okay, so no decimals or fractions on that. Okay, you can see all of the fun little informations about those. Again, we have this guy as your set of integers, right? Which should make sense because you are only getting integers out of this function. That's the whole point of it, okay? All right, and our last one here, the logistic function. So this guy is actually got two asymptotes. They're both of them are horizontal. So there's this dashed one that you're seeing here. But there's also one on your x-axis that you're not really seeing very well in that picture. So this guy is kind of like, some people get them confused. It's kind of like your cubing function, except it's like sideways. And cubing function, there's no asymptotes on either side. It still goes to the right for forever. It goes to the left for forever, but it just kind of has a similar shape where I will see people get them confused sometimes. Okay, this has two asymptotes on it. It is sideways. Okay, um, and equation's way more complicated using that irrational number e. So anyways, that's your logistic function. That's probably a new one for you as well. So yeah, we may end up using it some in this class, but anyways, those are your 12 different basic functions that we want to make sure that we know. So what we're going to do is we are going to answer questions these um, about these graphs, okay, or about these different functions. That is all I'm doing really, other than providing you guys with this information so you can get comfortable with it. All right, we're going to go through and we're going to we want to be able to make sure that you can match graphs with their functions, okay? And we want to be able to describe the function behavior. So you're going to see these types of questions in here. We have example 1 where they're saying, which functions do not have a domain of all real numbers? So you can go back to this lovely little sheet of paper and you can look for the ones that do not have all real numbers. Well, okay, I'm saying all real numbers, all real numbers, all real numbers. Nope. Reciprocal does not. Okay. So we'll write that one down. All real numbers, nope. Square root does not. Natural log does not. And I go down here, all real numbers, all real numbers, all real numbers, all real numbers, all real numbers. So there were only 3 that did not have a function or have a domain of all real numbers. Okay. So that would have been A. Our answers were the reciprocal function. That was our first one. Now I'm going to actually put its equation, y equals 1 over x. Okay. You could put its name, but I do need you guys to make sure you know not just the name of it, but I need you to also know the equation for it so that you can identify those. Okay. All right. The other one was the square root function. So y equals the square root of x. And then our other one was the natural log function. So that was y equals the natural log of x. Okay. All right, so that's part A. Now we need to look at part B, still continuing with domain. Now they said which function has a domain of all real numbers except for 0. So out of these 3, these were the only 3 that did not have all real numbers. This is saying which one of them it was really all real numbers except for 0. And why is that the case? Well, if you look here, and I know this is kind of zoomed out for you, but your domain here goes from negative infinity up to 0, 0 to positive infinity, okay? And that is really because there's just an asymptote there at x equals 0. So that would be our reciprocal function, y equals 1 over x. And the reason why is because there's an asymptote. At x equals 0. So that's why it's everything except 0. All right, C, they said which 2 functions have no negative numbers in their domains. Okay, so which ones have no negative numbers, only positive? Well, reciprocal did have negatives, okay? You look at there's stuff on the left side, you can see the negative infinity to 0, so that does have negatives. But square root does not. It starts here at 0 and goes to the right. There are no negatives, okay? The other one was natural log. There are no negatives, nothing on the left side of that y-axis. So we're going to say it's those 2. That was y equals the square root of x, your square root function, and also our natural log function. Okay. Now they said of these, which is defined at 0? So that one, they're saying which one does have a value at 0? Well, the natural log had an asymptote there. The only one that had a value where x was 0 is your square root function. So we're going to say have a value or a domain, sorry. We'll just say, here, we'll make it simple. Sorry, I'm trying to get complicated. That is defined as 0. That's what they asked, so that's what we should answer. Okay. So next thing, I have some more questions. So there's your example 2. It says, which functions have, so this time we're not talking about domain and range. This time we're talking about other stuff. Which functions have points of discontinuity? Which functions are bounded above and below? Which 3 functions are even, and how do you know? Okay, so here we go. Let's say A, we're going to say functions have points of discontinuity. Well, one thing you can do is use this little paper to help you. If it says continuous, then it does not have any discontinuity. So I'm looking continuous, continuous, not continuous. That's reciprocal function, okay? We have continuous, continuous, natural log, continuous, 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 but then greatest integer, not continuous. Last one was. So we only really had 2 there. I see 2. We had the square root function. No, it's not. Not the square root function. Where was it? There it is, reciprocal, sorry. Y equals 1 over x. And then we also had y equals, this was your greatest integer function, right? And that's just y equals your integer. Oops, integer. Okay, integer of x. So those do have points of discontinuity. Now B says which functions are bounded above and below. So really, I only know of a couple that are bounded both above and below. There are some that could be bounded other ways, but bounded above and below, that's your sine and your cosine. There's a place where they can't go any higher, can't go any lower. Ooh, there's a third one, logistic. Okay, so actually we've got 3 there. So I'm going to say we've got y equals sine of x, y equals cosine of x, and then y equals 1 over, that's 1 plus e to the negative x. Okay, those are bounded above and below. Last question on that example, which 3 basic functions are even and how do you know? So you can look at your paper where it says even, but you can also, like, you want to be able to know without having to read the paper, right? So what you look for is symmetry. I know a squaring function is even because it's a mirror image on either side. Reciprocal is not even because this piece right here did not repeat directly on the other side, right? So squaring is even because it's symmetrical, but the reciprocal function was not symmetrical across the y, okay? It is the same upside down as right side up, so that's when that's odd. So I know squaring is even. Okay, here's interesting. Cosine is even, but sine is odd. But they're so similar, right? Cosine is even. You notice how it went through the y-axis at that point 0, 1. Well, if you reflected on either side, this is the same, right? This is the same on either side. But sine is not that way, right? I might have a point right here, but it's not right on the other side. So that is not reflecting across the y-axis. It's not symmetric across the y-axis. Cosine is. So I would say that one is even. And that may, oh, no, absolute value, that one as well. So I'm looking at squaring, I'm looking at cosine, and I am looking at the absolute value. Y equals x squared. Y equals cosine of x, and y equals absolute value of x. Okay, and how do we know that they're even? There's symmetric, or there's symmetry across y-axis. Okay. All right, guys, we have one more example down here, questions to answer. So if y'all would look at that, again, you can always pause the video and write these things down. they've asked us to actually graph that equation. So whatever calculator you are using to graph with, you need to go ahead and enter this into the graphing section of it. I'm going to do the same thing with mine. So in case you happen to be using this one at home, remember that there is a free app that uses these numwork calculators. It's just, you look for numworks, and then when you pull these calculators up, it is exactly the same on your calculator on your phone as it is in your hands. So don't worry about that being different. Once you learn how to use the one on your phone, if you get comfortable with it, you'll be comfortable with these as well. All right, so let me finish typing this in. I got a little distracted, started talking. So I'm going to go back, and in case you're trying to learn how to use these, let me walk you through. Okay, so when you hit the home button, it takes you to this home screen. We're going to click on Graph. Okay, and then you can get rid of whatever is there just by hitting the clear button. There's a glare on that screen, so I'm trying to hold it. I'm going to hit the OK button. And then we're going to go down to the function option. And then we just type this in. We can move the left and right cursor if we need to. So I'm going to move it to the right to start some parentheses. Move it, sorry, that was to the left. We're going to move it to the right now to say -2, close the parentheses, and then we put a squared on it. And hit OK. And you can see what that graph looks like. Okay. Anyways, so what we're going to do here is use that to our advantage, okay? It says, on what interval is f increasing or decreasing? Well, this really is just a parabola that was shifted to the right 2 places. You could have told that from the equation too if you just remembered how that transformation works. But they said, where is it increasing and decreasing? Just for the sake of making this a little bit easier on us, I am going to show just a rough graph of this because it's not showing very well on my calculator screen. It's got that glare and it's kind of a light color. Okay, so this is a parabola that goes 1, 2 to the right, and then it's probably not this wide, but it's kind of that shape. Okay, so they said, on what interval is f increasing and decreasing? So let's talk about what is it doing to begin with. Well, as it begins, we are going down, right, with our figure. So it actually starts with decreasing. Okay, we're going to give intervals for increasing and decreasing. So it actually starts with decreasing from -infinity all the way till my x is 2. So I'm going to say from -infinity until 2. And then once it hits 2, it's going to turn and increase. So from 2 to positive infinity, it increases. Okay, now they said, is f even, odd, or neither? Well, here's an easy way to tell. This is not symmetrical across the y-axis. You see that there was this turning point here. There was not another one over on this other side, right? That is not symmetrical across the y-axis. Also, if you turn this upside down, it's not the same as it was right side up. So it's not even, it's not odd, meaning it would be neither. All right, does f have any extrema? Yes, it does. It's got this little lowest point. It's got that absolute minimum down there. So yes, we're going to say we've got an absolute minimum, and that's at the point 2, 0. Okay, and then we got part D. How does f relate to the basic function y equals x squared? So it's basically asking, how does it compare to the parent function? Well, the parent function would have looked very, very similar, except it would have gone through the origin. So that's what that would have done, right, in green. But purple is what we're working with here. This guy has been moved to the right too. Okay, so we're going to say has been horizontally shifted 2 units right. Okay. So that's the type of thing that we're talking about here, guys. As far as being able to answer the questions, if you know what the figure looks like, then you should be able to answer all the different types of questions based off of what we learned in section 1.2. However, this is just a nice little at a glance. Here's all the functions in one place. And these are the types of questions that they like to ask us here in section 1.3. Okay. So that's that for this section, guys. Much shorter than 1.2. And I will see